when we look at a function like this, let me know if you can see or if there is any problem anytime. So if we look at a function, let's say this is x equals 1, and this is the function, like we have in this situation. So you notice that as x approaches 1 from either side, one limit is infinity, the other limit is negative infinity. So of course I will write that the limit of function f of x as x approaches 1 from either side, but I have to explain why. This goes to infinity and this goes to negative infinity. I will write the limit from the left, I will write the limit from the right. One is positive infinity, the other one is negative infinity. The reason why this is d and e. And that is called, as we know, x equals 1 because of this. Actually, because of the infinity and negative infinity, not because of that. Because infinity, at least one of these sides is infinity. X equals 1 is a vertical asymptote. And the function will never cross a vertical asymptote. Also, look at what I graphed here. As x approaches negative infinity, the function values get closer and closer, closer and closer to 0. Same thing on the other side. It doesn't have to be. It can be on this side to -1 or something else. But the way I graph the function, so which means y equals 0 is a horizontal asymptote. How do I determine that? How do I show that? By showing that the limit of f of x as x approaches negative infinity is a number, in this case 0. And the same thing, it happens on this side, that the limit of f of x as x approaches infinity is also 0. Because of this reason, then y equals 0 becomes a horizontal asymptote. Any questions? Any questions for me? Okay, so we are moving on to 1.2. If you have any questions, you can stop me anytime, always. We're going to talk about limits, again, with rules, limit rules, and algebraic ways of finding limits. Okay, so let's list the rules for finding limits. So there are several rules. So let's start with the first one. A limit as x approaches a from either side of f of x is a number L. So these are the assumptions. Maybe I shouldn't put 1 in here because these are my assumptions first. And let me not put 1 there because this is not the first rule. I need my assumptions first. So sorry about that. I don't want to confuse anyone. This is not our first rule. Okay. So assuming that the limit of f of x exists, so this is a number, exists, a number. As you know, if it's d and e or infinity, the limit does not exist. But this is a number, and which means that the limit exists. Also, the limit of g of x as x approaches a from either side exists. We're going to call it m. It's a number, another number, so it exists. So these are our assumptions. Without these assumptions, we cannot proceed to listing the rules. So these are our first. Here will be our first rule based on the assumptions. Everything is based on these assumptions. Here's number 1. The limit of f of x plus g of x as x approaches a, don't forget parentheses around f and g, if the limit of f of x and the limit of g of x, as I explained here, if they exist, then we can write, and no, I am not distributing the limit operator to these two. It only means that this limit can be determined by finding the limit of f of x and adding it to the limit of g of x. So please don't say that we are distributing this operator here. No. This is a rule that says that the limit of the sum is the sum of the limits if the two limits exist. And then, because this limit is L, I'm going to write L. Because this limit is M, I'm going to write M. So here is our first rule. Allow me to condense this. So if I have here minus, this is it. It's the same rule. If I have a difference of two functions and I apply the limit to it, then it's okay to separate the two limits. Here's an example, or maybe I should say maybe a counterexample. The limit of 1 over x plus the limit of x as x approaches 0. Can I write the limit of 1 over x plus the limit of x as x approaches 0? Well, I'll help with this. The answer is no. No. And here's why. The limit of x when x approaches 0, well, let's look at the graph. This is x, y equals x. So it will pass through the origin, so as x approaches 0 from either side, this number will be 0. But if you remember how we graph this function, it's an important function, a rational function. Let me remind you how we graph this. Very important. It's this. And we called it odd because it's symmetric with respect to the origin. And here's 0, right? So what happens here? The limit from the left of 0 is what? Can anyone say something? The limit from the left of 0.
Must not exist.
Negative infinity. The limit from the right of 0.
Positive infinity.
Great. So that's why this, as Mallory said, is D and E. So the limit from the left is negative infinity. The limit from the right is positive infinity. So that's why this is D and E. So therefore, I cannot use the limit law. Why? Because this is not a number. It does not exist. So we always have to be careful when we apply this, any of the rules, and make sure that the rule is applicable. Here, the rule is not applicable. This exists, but this one does not.
So, question. When you have it written out where it says the limit as x approaches 0, and then in parentheses you have 1x plus x, you're saying that because what I'm trying to say is on the right, where you have it on the right, like we couldn't basically it's just saying you would have to have it separate like it is on the right. You wouldn't try to like shortcut it and do it how you have on the left of that equal sign.
I'm only saying that this limit does not equal this. I cannot apply the rule.
You can't, okay, you just can't, okay.
It does not comply with the assumption. This limit that complies with the assumption, but this one does not. Good. Moving on to 2. The limit of a product as x approaches a. Yes, I'm sure you're guessing that this is the limit of f of x multiplied by the limit of g of x as x approaches a. Assuming that conditions are fulfilled. What does this limit equal to? So I'm going to continue here. What does this limit equal to? Anyone?
Sorry, can I get the question again? I was still writing the
Sure.
above part.
Sure. What does this equal to?
Is it 0?
Limit of f
The
of x
L?
as x approaches a from either side is
L.
limit of g of x as x approaches a from either side is
M.
excellent. So what does this limit equal to?
L.
Good. What does this limit equal to?
M.
That's it. Moving on. Excellent. Number 3, page 3, and also rule 3. Limit as x approaches a from either side, of course, from f of x over g of x. What do you think this equals to? Wild guess. Assuming conditions are fulfilled.
L over M.
Yes. Limit of f of x as x approaches a over limit of g of x as x approaches a. And it is L over M, comma, if, a big if, which I did not have before. What is the big if here?
M doesn't equal 0.
Or
Excellent.
the limit. Okay.
Excellent. Otherwise, the whole thing collapses. Awesome. Thank you. Who was that, Kimmy?
Yes, ma'am.
Thank you. Good. Number 4, the limit of a constant as x approaches a. Wild guess. What do you think? Who cares where x is going? The constant, where will the constant go? And the answer is nowhere. Nowhere. 5, limit of a constant times a function.
I'm still finishing up writing down number 3. I'm sorry. I'm trying to catch up.
Yeah, it's just a lot of writing, but it's really nothing, I would say. Good. Can anyone tell us what to do here? And this is extremely important. If this is a factor, if c is a factor, meaning it's multiplied or multiplies c, c multiplies f of x, this can be taken in front of the limit. So this is c times limit of f of x as x approaches a. And since this limit is how much?
L.
Sure. So this would be c times L. Awesome.
So it kind of works like logarithms in a sense?
But
Or no?
because
There.
the limit, the c will be up here and move in front if this were a natural log. But you're
yeah.
right. You're right. It's a property that is somewhat similar to that. Good. I agree. Okay, number 6. Now let's look at a power. So limit of f of x raised to power m as x approaches a from either side. Well, this is something that I do a lot with my STEM class, my regular calculus class, the swapping of the operators. So this operator can go and touch the function, and this can, which touches the function, can be outside. So this is limit of f of x, but we are not really using this property a lot here, so I'm not going to bother you with it. So the limit of the function to a power is the same with the limit of the function, everything raised to that power. And since we know that this is how much?
We're assuming L, correct?
We're not assuming. I mean, if you want, yeah, these are the assumptions, but this was the premises from the very beginning. We said this is the case. In other words, it's a number that exists. What number? We don't care at this point. So yes, it's L to the power m. And of course, this m can be a radical, right? So I can have limit of the mth root of f of x as x approaches a. And of course, this has to have certain conditions. It has to be a number greater than or equal to 2. And the same property applies. The limit goes inside, touching the function, and the mth power goes outside. So this is the mth power of the limit of f of x as x approaches a from either side. And since this is how much? According to our assumptions, I agree.
L.
Yes, so this will be the mth root of L, also written as L to 1 over m. Remember, 1 is the power, the numerator, the power is the numerator, and m is the index, which is the denominator. Okay, enough of these rules, and I would like now to look at a few problems and then move on to continuity, basically. I would like to look at a few examples on page, let's see, where is my screen share here? Okay, can I just, let me see, which page is the next? Let me see, I think it's 124, yeah. Where's my keyboard? I don't have enough room on the table to put the keyboard in front here.